Let's look at a couple more examples working with confidence intervals with population proportions. So the figure below is from a survey of 800 US adults ages 18 to 29. Construct a 99% confidence interval for the population proportion of 18 to 29-year-olds who get their news on television. Excuse me. So looks like 27% of the 800 people surveyed get their news on television. And talking to my class, that sounded about right. Not many of my students in class actually even watch television anymore. So it was kind of a low number in class. So to do the confidence interval, notice how we needed to know the number of successes as well. We know the sample size is 800. But notice how if we do 27% of 800, that tells me actually how many people get their news on television. So if we do 0.27 times 800, that gives us 216. So 216 adults from the ages 18 to 29 out of this 800 actually get their news from the television. And also how the confidence interval level is this 99%. So what we can do is just let the technology build this confidence interval for us. So if we go to stat, go to test, go to that A, the one prop ZN. So that's our proposition. And again, we use that critical value Z for that. Notice how we will put the 216 in as our successes. Those who actually watch news on television. 800 was the number of people surveyed. Our confidence interval level was 99, actually. That's how confident we want to be. So if we do that, so if we round this to 2 decimal places, we're going to get 0.23 to 0.31. So what we're seeing here is our population proportion. We're going to see that our range is going to be between 23% and 31%. This is kind of what we're going to see. And notice how our sample was this 27%. So notice how our population proportion, we're going to be 99% confident that our population proportion is going to be between 23% and 31%. So another question we have is finding the minimum sample size. So here it talks about one way to increase the precision of a confidence interval without decreasing the level of confidence is to increase the sample size. But the catch is, how far do we actually want to increase it? So we have a formula here that says, given the confidence level and the margin of error, the minimum sample size N needed to estimate a population P is given by this formula. So notice how it really is the formula we had up here to find the margin of error. It's really this formula here solving for N. So this formula here has just been algebraically manipulated to solve for N. And I'll save you, I won't solve that for you. We'll just let it play out here. So if we do this math, if N is not a whole number, we round up to the next whole number. Also, there's a little fine note here that says, if you have no preliminary estimates of P hat and Q hat, you're going to use P hat as 0.5 and Q hat as 0.5. So 50%, 50% if we have no preliminary estimates. So that'll help us create the minimal sample size. So you're running a political campaign and you wish to estimate with 95% confidence the population of registered voters who will vote for your candidate. Your estimate must be accurate within 3% of your population proportion. So that's going to be your margin of error, if you will. Find the minimum sample size when, one, no preliminary estimate is available. So notice how they're wanting us to find N, but if there's no preliminary estimate available, we're going to use 0.5 and 0.5 for those. So we have 0.5 and 0.5. Our critical value Z comes from this 95% confidence level. So I think we wrote those down up here somewhere, so we don't have to go look that up every time. So 95% is this 1.96. So we already got that down. So 1.96 was our critical value Z. And 3%'s got to be turned into a decimal, so it's going to be at 0.03, and that's going to be squared. So this will give us our minimal sample size. So if we can do that calculator there, 0.5 times 0.5. And then I'm going to go ahead and use those fractions again. So I'm going to go the alpha button, hit the Y equals button to activate this little menu up here under F1. I want to use the N over D. So I'm going to put this 1.96 here. And then 0.03 at the bottom. Come out of there and square that. And then square that. Square that, I should say. Hit enter. So it looks like if we round it up to the next whole number, that's going to be 1068. So they're saying our minimum sample size would be 1068. So I would be 95% confident that 50% of these voters would vote for my candidate with a 3% margin of error. Now, part 2 says, suppose the preliminary estimate says that 31% of the population is going to vote for our candidate. So if we do that math, our minimal sample size, we only want 31% of the people to vote for us. So Q hat means there's going to be a lot that are not going to vote for us. So 1 minus 0.31. So 0.69 are not going to vote for us. So the rest of this stays the same. So since it looks like we're not looking for as many people to vote for us, our sample size probably doesn't have to be as much either. That looks okay. I don't know what button I hit. Hit something. That looks okay. So yeah, looks like 913. So it looks like 914 since it's a decimal. So it looks like minimum sample size has to be like 914 if I round up there. Okay. So that takes you through some of the questions in 6.3. Hopefully you find that helpful.